results and some applications and our work in Brazil related to cultural heritage, of course. Then my presentation is divided in some special issues. The first one is the relevant success cases. And I'm going to divide with research and develop that we are doing with ionizing radiation, study some specific matters like photographic films, further work on botanical collections, and another part with nanostructured cross-linked polymeric hydrogels obtained by ionizing radiation to cleaning surface of artworks. I'm going to present the basic guidelines we use in Brazil to the contamination objects, some general remarks. Of course, my institute, I'm part of the Nuclear and Energy Research Institute, and we are under the National Nuclear Energy Commission and under the Ministry of Science and Technology of Brazil. We are located inside our campus of the University of Sao Paulo, a big area. And of course, we are at the south of Brazil, very, very south part of this big country. And then how this technique is become a good acceptation and application, because of course the weather of Brazilian conditions proves the tangible materials organic sensitivity to these conditions. And we have a lot of disasters, of course, most of them related to water, to the flooding conditions in different parts of the country, like you can see on the left side of the slide. And of course, to get these words, have the action of the insects, termites, and another one. And of course, the fungi attack is evident when the conditions of the humidity is very high. Then, in our approach in this, my institute and our laboratories and then application of this technique, we divide this ionizing radiation in three different issues. The first one is the disinfection by ionizing radiation. When you were working with material characterization, research and development of several materials, because most of the research around the world were done on paper. And you need to know the limitation of the materials for emergency interventions, of course, and mass contamination when it is necessary. Of course, like Logan says, consolidation by ionizing radiation is important too, and you can use resins, polymerization, like cross-linking process. And the third one we're working is the development of new nanostructured materials for cleaning surface. And we're working with mixes with natural polymers, blends. Then all of these were done at the multiple purpose gamma radiation facilities. Gamma radiation facility developed, made in Brazil, totally made in Brazil. Is working more like almost 20 years. And we have a strong interaction programs with the conservation and the preservation institutions and with the diffusion materials irradiation techniques using the national support and the EAA especially support. I suppose that since 2004, we were processing more like 50,000 cultural artifacts. I want to show you some important cases, for example, related to mass contamination. We were working especially with the University of Sao Paulo institutions, helping them to solve a lot of cases related to books collection, attacks for insects and fungi. And of course, this is very common in this kind of libraries of collections, and gamma radiations become a good alternative to solve mass contamination, like you see in the pictures, the material waiting to be irradiated or to be disinfected in the located not irradiated materials, and divided for, of course, special different regions around the surface of the multipurpose facility. Of course, we help them to the university or and other schools, for example, with projects, original projects, like because poor storage conditions become attacked by fungi. And if not was available, the radiation technique, I think was possible to take a lot of time to solve the problem of fungi inside of these materials. We work too with rare books collections, of course, preservations, helping people to process incunables, books from around the beginning of the printer era from Europe. Probably we process more like 5,000 Asian books for irradiation. Large objects are another special case, for example, in this process for the Pinacoteca State or State Sao Paulo, we irradiate a 1 ton sculpture. Of course, the difficulty was put inside this big sculpture inside the irradiation chamber. But this is, we solved the problem, we had them with a special issue of size. The same is a special case when I infected painting from canvas, from some exportation objectives, but the idea that was too big, it was too difficult to put inside of the irradiation chamber. We worked together in collaboration with the restoration and conservation people, and they disassembled the painting in a roll to have the special size to put inside of the irradiation chamber, and we solved the problem of fungi inside too. This is a really remarkable process. Like we have the biggest program, the most important research center in Sao Paulo, Mário de Andrade Public Library. We have a program with renovation works and with programs on the condition of air. Like we started a program with fungi in almost 15 floors, affecting more like 8,000 volumes of books and other documents. Of course, we have them and we do our research together to prove to them that the gamma radiation is more effective, like another techniques like you see in the down part of the slide, which after irradiation is not growing of fungi, in this case, penicillin. Modern art is a very important part of our activity here. We irradiate people from the government of Sao Paulo or private restorers and conservation companies too. And of course, it is not too easy because it's a mix of materials, organic and inorganic materials, polymers. And, but we have an excellent resource with this work. And in this case, the remarkable work were done with the program in the state of Bandeirantes in Sao Paulo. We process the modern Brazilian painters, like the more important, like in this country in some stage of the time, but it was very not too easy because the size of this kind of paintings were around 2 or 3 meters of length. Of course, we work with another art museums, helping them, doing partnerships to help them in some programs and expositions when they will find problems with insects. Especially, we work with ethnographic collections too, helping them with insects when arrive to this collection to not spread the contamination with another pieces inside of the museums. Of course, if you visit Brazil, I invite you to visit the Afro Brazil Museum, a very nice place to spend one day maybe. We have people from another schools in the University of Sao Paulo. For example, this is a case with Waxworks that at the past, the students of medical school use like a model to understand the dermato diseases around skin. But for some years, they left behind these kind of objects, and when they start to show on the historic museum, they found a lot of problems with insects, and then in collaboration with the restoration and conservation people. And of course, we process a lot of formative gamma irradiation with different kind of museums, institutions, and desks, and a lot of material, especially made in wood. Well, to do this, to have success in all these kind of applications, we need to develop a lot of research and development, of course, in another kind of constitutive materials, because all materials have different behavior around the different doses applications. And this is a special case, and we work with people from my institute, and we study what are the limits to conserve photographic and cinematographic films, because this was a problem inside the archives in the university. Of course, Brazilian weather is a problem, fungi contamination, of course, and now have a plus, the vinegar syndrome, like is a consequence of the contact of the water or high humidity with this kind of material, like create a chemical reaction to return to the original chemical compounds, and this is called, because it's called vinegar syndrome. When we develop a research model, we do a sample films for the university local collections, and we use characterization with some techniques. I will radiate using gamma and using electron beam, two different techniques. And of course, we evaluate the effects of the irradiation on the films. Then we do some results with infrared and ultraviolet spectroscopy to distinguish the change. Of course, we do microscopy to analyze different regions and composition of the materials, and thermal analysis to verify changes in the polymer conditions of the material or irradiated. The conclusions were that disinfection with gamma radiation and electron beam can be target safely between 6 and 10 kilograms with no significant modifications. And by the other side, we irradiate with high doses. We found that if you use a dose of 50 kilograms and very high, you can induce a cross-linking to stop the vinegar syndrome. They can be useful in some kind of conditions of the material. All of this information is published now in a journal, Scientific. Another research we did, very important for because of the conditions of the collections of Brazil, is the further irradiation in further work. It's part of a lot of issues in this country. We work with students, researchers for the institution and for the university. Well, the idea is that this kind of material is remarkable. It exists in a lot of countries, but a lot of problems exist with this kind of collections. The structure is very complex, it's not too easy. Keratinous attachments, biopigments, and carotenoids, melanin, for example. But we know that is a biological cycle of organic materials because of problem of Brazilian weather and problem with insects, moths, and proliferations on another places. Then we start the same approach for the research, selection of the samples, irradiation. Now we irradiate with high doses only to see what are the limits of the materials. We do colorimetry, microscopy analysis to verify the morphology of the materials. And we verify that until 50 kilograms are not changing in the color. The human eye cannot realize a change of the color until 15 kilograms. Of course, 15 kilograms is not necessary for this material. Maybe 1 kilograms is enough, but because was a research, we did this approach. The same with microscopy, we will not find effective radiation on the structures of the material. Of course, condition conclusions on this can be disinfected, can be, and the higher doses are not necessary for these treatments. Another research we did with another special material, this very susceptible bio-irradiation, like in the botanical collections called Sexicata. And we work with special herbarium and a team of people here. The same thing. We choose the material from the herbarium of Sao Paulo, and after this chooses sample, we radiate in different doses in different conditions. We select points because it's not homogeneous material, it's not easy. 3, 4 points, different sizes of the flower leaf. And after that, we apply the techniques to find what happens. The same conditions, we found no morphological changes. And it's they change no color. The total color is not changed until almost 10 kilograms. That is a good news because you can irradiate and you're going to change the conditions important in the materials. Then the condition is special. Gamma irradiation can be applied and to irradiate, of course, eradicate insects and to disinfect the materials. On the third part we're working now is developing new nanostructured cross-linked polymers. And of course, like the form of hydrogels using ionizing radiation. This is because exists traditional hydrogels, but they are obtained by physical and chemical process. Sometimes this process have limitations, including preparation time, storage, and stability. The idea is, of course, is irradiate this material to get greater stability, extend the shed life, and produce specific physical chemical properties, increasing compatibility in some special material. Of course, for example, delicate matters or tangible shapers. And we're working inside a pattern here, using natural and synthetic polymers to obtain the materials, irradiating and applying. You can see the results here. Some hydrogels in different composition, including with nanoparticles or not inside, depending on the material. And of course, examples of the applicability of the preliminary cleaning tests. You can see the paper on the right paper too. The first one is the original, B, applying the material after 10 minutes until 3 hours. Here are the preliminary results. We're trying to do some computation with these materials here. And finally, we were working some years, and now we are working with Banca and the team with the EAA, Laurent, and other people, develop basic guidelines. However, in Brazil, we were working in this issue on 2 or 3 years ago because it was a necessity inside to help people to understand how the process works. The idea is to promote a diagnosis of the status of the collection, finding for things, symptoms, state of conservation, environment guard, associated pathologies, contamination examination, previous irradiation, because the cumulative effect, classification of the province, presence of the insect, presence of the insects and fungi, bacteria, and the quantity. After that, we were working with special basic line, dividing some introduction for the people, subject, the application, condition, terminology, and definitions, pre-treatment of materials to be decontaminated. In case of need for packing, materials are already packed, exceptional dimension and masses, what you can do, what is the kind of the registration, transportation of these materials to the facility for the supplier, from the supplier, and the stage of the contamination, how we receive this material, how we store these materials in this facility, and in the irradiation, how we pre-treat if necessary, what dose we apply, what verification we do during the treatment, and of course, the procedures after irradiation. Of course, we need a report and documentation. Because we don't have more time, I cannot explain every some of these single points, but all of them are very important. But very important too is the procedures after irradiation. All people think that irradiate, we irradiate our product and with the process finishing. Not. You need to do a process for remove the mechanical or manual dust on the insects, dead insects or the fungi, etc. Because it's a part of the process of the hygienization before to put in the new place for store. Then it's very important to show the. And of course, you have a special project to digitalization for rare books or special material you can do, like the University of São Paulo is doing. Then I can see that the purpose of this manual is to be a practical guide from detection, the problem to final hygienization, to promote conservatives and professionals of irradiation to work like collaborative, and we have the same objective to have a purpose of the treatment. And I can see that the decision of the process with the ionizing radiation must be carried out by professionals of the conservation of cultural heritage in conjunction with professionals with the field of ionizing radiation, facility or university or private school. On general remarks, I can see like this disinfection can be applied with success, but you need, of course, research to study what are the effects. I can help you in some situations to find materials affected by climate disasters. And I can see finally that the national interregional cooperation projects are very important to have the acceptance of technology, and this is an example in Brazil. Thank you very much.